In this lesson, we're going to begin to look at the RL circuit when the current is decreasing. Now, as it says here, when the current is decreasing, you will start your analysis with the switch at position A, and it's been there for a long period of time. That's the t equals infinity. So we're assuming we have reached a steady state value based on a time of t equals infinity. So, when the switch is switched off of position A, what we get now is a very interesting result. That spike voltage, which is our induced voltage, so that spike that occurs, can now actually be much larger than the battery voltage. So if it's interrupted abruptly, we can get a large spike actually ionizing the air in the gap between A and B. So you actually get like a little, let me erase this. You actually get, if you want to put it in here, like a little lightning strike, right? So we get right? So you get a little lightning strike. It ionizes the gap. When it's abruptly opened. And that basic notion is how your car ignites the fuel-air mixture using the spark plugs and a ignition coil. So what I have here is kind of what happens when you plug the key into your car and begin to start the engine. What actually is going on inside the car? You can now understand it because fundamentally it is a solenoid. If you look at your ignition coil, so if your mechanic tells you, oh, you have a bad ignition coil, you know that you are talking about having a bad solenoid. So we have a solenoid. We can zoom in here if you want. See the solenoid that is in there. We have a capacitor that's helping to charge and discharge those coils. We have a contact breaker, which is our switch opening and closing. So the breaker, that contact breaker, is language that is used because it breaks the flow of current to the ignition coil, which then spikes a voltage, right? So we get a voltage spike in here that gets translated up to what is called the distributor, which distributes that spark between the different spark plugs. And that spark is also controlled by a camshaft, which opens and closes the intake exhaust valves for the flow of the fuel-air mixture to the pistons, and that is the basic premise for how the spark plugs get that voltage and the ability to be able to spark. So if we understand Faraday's law and understand these voltage spikes based on di dt, then you can understand the basic premise for how that internal combustion engine works. Now, in our next lesson, we'll talk about the mathematics involved in looking at the RL circuit as the current decreases, just like we looked at the RC circuit in both the charging and discharging cases.